All right, so hold on. Didn't start recording. Vocabulary review. Is this number a repeating decimal or a terminating decimal? Is this number a repeating decimal or a terminating decimal?
I'm going to say, since there's no line on top of it, that it's a terminating decimal.
Okay. Do you have to have a line above it for it to be a terminating decimal? No. What does the line mean?
That it goes on forever.
Right. So that means there's a block of numbers that repeat and it doesn't have an end to it, right? That's a repeating decimal. Okay, in this case, there's no bar above it, so it does terminate. Okay, we're gonna talk about other decimals that that do not terminate. We're gonna learn about those a little later in the book. Okay, so the answer for this is a terminating decimal. The decimal stops. Okay, write each fraction as a decimal. Do you guys remember how to write a fraction as a decimal? Some of these you should memorize, right? So, Uche, can you tell me number 2, what is 3/4 written as a decimal?
0 and 12.
If you don't know it, what can we do to my fraction? How do I rewrite that so I can find out what it is? I can divide. So walk me through that. So the top number is 3, and I'm going to put 3 in the house. Very good. And 4 is on the bottom of the fraction, so I'm going to put that on the outside of the house. Very good. So there's 4. Right, I need to put my decimal, and it's just to the right. If I have no decimal, I can always put a decimal there. I'll put a couple zeros. Remember what we call that when we put the zeros in there? Do you guys remember? We're going to annex some zeros. I put 2. I don't know. We might need more. We might need less. Okay, so, Uche, how many times will 4 go into 3? 0 times. Okay. Now, if I continue, there's something I have to do. What do I have to do next? Bring my decimal straight up. And if that's a bad spot for you, because I can see you're squinting. Do you wear glasses? Okay, you might need to get that checked out. Can you move up to the front? Because I can see that you're squinting back there. So how many times does 4 go into 30? 6. 6 times 4 is 24, right? Can we get closer than that?
Yes.
7. 7 times 4 is what? 20 what?
28.
Right. So let's subtract that. 30, take away 28, so what's that going to be?
Well, you take what? 2.
It's going to be 2. I'm going to bring down the 0. How many times does 4 go into 20? 5 times. So 5 times 4 is 20. And I get a 0. I'm done. This is a terminating decimal. So 3/4 is equivalent to what fraction? How do I say that number?
What was the question? What was the question?
How do I say that number? My answer.
0 and 7.
0 and 75. What's the place?
75 hundredths.
Right. Okay. Somebody go ahead and walk me through number 3. Can somebody walk me through number 3? I'm going to go up and down the rows. So I'm going to go all the way to the back of the second row there. Terrell, what's the first thing I got to do? Uh-huh. Okay. Right, and so how do I set that up? I make my house, okay. Okay, then what? 9 is on the outside, very good. And 7 is on the inside. Okay, am I done? Can I start? Okay, so you're saying go ahead and put my 0 here and here? Yeah. Okay, but before I even do that, what should I do? I'm not done with what's in the house, right? What do I do? Put a 0 next to the 7, but I also got to put that decimal there. And I'm not sure how many zeros I need to annex, so I'm going to put 2 just to start with. Okay? So does 9 go into 7? No, you already put the 0 up top. But does 9 go into 70?
Yes.
How many times? Terrell, how many times? What do you think? 7. What's 7 times 9?
63.
Yep. So 7 times 9 is 63. We're going to subtract that. What's 70 minus 7? What's 70 minus 63? 7. So I bring down my 0. Are you already starting to see something happening? Okay. How many times does 9 go into 70? 7 again, but we're starting to see a pattern here, right? So we'll get 63 again. And then the remainder is 7. So how do I show that I have something that's happening again and again? A number that's a block of numbers or number that's repeating. What is that? Right, it's a repeating decimal. So I'm going to put above which number in my block? Okay, I don't need to put it above all of them, so I'm just going to put it above my first one. Okay, and then my answer is 7/10 repeating. Yep, I got a question. Ola?
Is that a negative sign?
Yeah, that's what else we have to take care of. We're getting to that. So the fraction's negative, so we're not quite done, right?
No.
So what do I got to put in front of my answer? Well, the fraction's negative, so that means the quotient, when I get this decimal, the resulting decimal, that's going to also be negative. Okay, any questions about that one? All right, let's go ahead and take a look at number 4. Well, we already know how to deal with the whole number, right? Remember that from last week? We got to figure out what 1/3 is, right? Some of you guys might already know what 1/3 is without even dividing that out. That's one of those 3/4, 1/3, 1/2. There's a few of them that you should already kind of have memorized automatically, and because you'll see them so often. But let's go ahead and work out number 4. So first of all, we already know 4 is going to be 1, and we got to figure out everything to the right. So we got this fraction, 1/3, and then we got to rewrite that. How do we do that? Go ahead, Rudy.
You put the 1 in the house.
Okay, 1's going to be in the house. Very good. So my 1 is in the house.
And you put 3 out in the house.
And then my 3, my denominator is out of the house. And then I got my house. Okay. Put a decimal after 1.
And then you bring the decimal up.
Bring my decimal up. Yep. And I got to annex a couple zeros. 1 or 2, doesn't matter. If we need to add more, we'll add more. If we need to discard some, we can discard some. So does 3 go into 1? Nope. It does not go into 1, so we have a 0 up above. Okay, does 3 go into 10?
Yes.
How many times? 3 times. And then 3 times 3 is what? 9. Now we got to take the difference of 10 and 9. What's the difference of 10 and 9? 1. So we're going to bring down this 0. 3 goes into 10 again. 3 times. And then 3 times 3 is 9. And we already see that there's a pattern emerging, right? So my answer is going to be what? I'm going to get rid of this. Well, I'm actually not going to get rid of that. All right, so we know that this comes from the fraction 1/3. Okay, and we're going to add that 3 from my quotient, and 3 is the block of numbers. In this case, it's a number that repeats. I'm putting my repeat sign over the 3. Okay, is that what you guys got? Okay, this last one. Can we simplify this last one? So I'm going to do something a little differently. I could do long division. Did somebody have another strategy? Somebody have another strategy? Olamide?
I divided 40 divided by 2. I divided that by 2.
Okay, so you divided the numerator and the denominator by 2. Okay, and what did you get in the numerator?
I got 6.
Okay, what did you get in the denominator?
And I got 24.
Okay. Is this simplest form?
No.
No. Can we keep going? Let's go. What's next?
And I divided 8 by 2 again.
By 2 again? Okay, so here we're going to divide by 2 again. And then what do we get?
I got 4.
6 divided by 2 is
Sorry,
3. And then 24 divided by 2 is
12.
12. And we're not quite done. We can keep going, right? And you're saying this becomes what? 1/4. And can we say, what? Do you know just what 1/4 or a quarter is as a decimal? What is it? What is it? 25% or 20, not a percent, decimal and percent. They're related.
2500.
Hundredths, very good. So my answer is 25 hundredths. And this is a terminating decimal. Okay? You can verify number 5 the same way we did number 4, 3, and 2. Okay? And then here are my answers. Okay? Any questions? This is all review from last week. Okay, moving right along. Okay, who likes to buy things on sale? You like to pay full price for everything? Depends on what it depends. I don't care what it is. I don't want to pay full price. If I can save some money, what am I doing? That means I have money to save and buy something else with, right? Okay, so I hear what you're saying. Just because something's on sale doesn't mean you have to buy it just because it's a good deal. It's not a good deal if you don't need it. Have you heard of that before? Yeah. Okay. So, but sometimes when you need something, you try to shop around to get a better deal. Have you guys ever done that? Do you guys have an allowance? No. Do you ever have a budget? Have your parents ever, maybe it was Christmas money or a gift or something, and then you want to make sure that that gift, that money that you had went a long ways? Maybe you had it for a trip, a field trip, and you were trying to decide, okay, do I eat or do I go buy this silly toy from this gift shop? Okay, some of you guys would rather have that toy. Some of you would rather eat. Okay. I will not be calling some of you guys to be my financial planners. I can tell by some of your comments. Can I get somebody to read through this? Actually, I'm going to read through this since I'm making the video. What you'll learn: to compare and order rational numbers. New vocabulary: rational number. Why learn this? Rational numbers are part of everyday life. You can see them on price tags, highway signs, and charts. Rational numbers can be written in different forms. To compare rational numbers, it's easier to convert them into the same form. So we already kind of talked about this with ordering decimals and fractions earlier last week. Do you guys remember last week we talked about that? So this is a little bit, this is going into a little bit more details, being more specific. What is a rational number? Okay, a rational number, if you take a look, a rational number is a number that can be written as a quotient of two integers where the divisor is not 0, and you're going to learn about that later in math. You cannot have a 0 in the denominator. You can't divide by 0. That's something that does not exist. Okay, so you can't have a fraction where the denominator is 0. Okay, so here's some examples. 2/5, 3/10, 3 repeating, -6, and 3 1/2. Can I write all of these as a fraction? Okay, 2/5 is already as a fraction, right? 0 and 3/10 repeating. How would I write that as a fraction? Didn't we just have that? Hola? Right. So this right here can be written as 1/3, right? And we already saw that in the warm-up, didn't we? Saw something similar to that in the warm-up? Okay. -6, can I write -6 as a fraction? We can write anything as a fraction if we do what? If it's an integer, I can always write any integer as a fraction. How do I do that? Fatima. Yes, you could write as an improper fraction. So how would I write negative 6 as an improper fraction? Olamide?
So the denominator will be 3.
No, negatory. Somebody else? Glorabelle, you got an idea? This is a trick that comes up a lot in math, so listen to me. I could turn anything into a fraction if I put it over 1. Is that what you're about to say? Well, you put your hand like by your hip. I don't know if you're like scratching your hip. You need to put it up. But Alexandra, you were going to say put it over 1. So what Alexandra was going to say, I apologize, I didn't call on you, but you're correct. Negative 6 over 1, that's an improper fraction, but you could turn any integer into a fraction by putting it over 1. What's 6 divided by 1? It's 6 still, right? Okay, and then a mixed number, can I write a mixed number as an improper fraction?
Yes.
Where the numerator and the denominator will both be integers, and the denominator is not 0. So, how do I rewrite this? Shh. How do I rewrite this? Some of you guys didn't show all your work in the homework.
17.
What's the first step? Some of you guys are losing points because you're still not showing work. For this problem right here, 3 1/2, if you really want to show it, there's another method. 2 times 3, and then I add the numerator, and that's all over 2. And when I simplify that, I heard it in the back, what's it going to be? 7 halves. So this right here is equivalent to 7 halves. Okay? Do you guys see what I'm talking about showing your work? If you just show me this and then the answer, you're going to lose some points for that. Okay, take a look at these two. We're going to compare these two fractions. When they talk about comparing, it's less than, greater than, equal to. Well, first of all, are these two equal to each other? So if I'm comparing negative 1/2 and negative 3/4, are they equal? Well, what is negative 1/2 if I rewrite that as a decimal? Go ahead, Logan. Negative, you could say 50 hundredths, or you could also say negative 5/10. Very good. Oops. I keep messing that up. Okay, what about this other negative 3/4? What's that as a fraction? Didn't we just do that in the warm-up? Abu, what is that?
Negative 75 hundredths.
Negative 75 hundredths. Now, let me ask you something. On the number line, which one's going to be farther away from 0 on the negative side? Negative 3/4. So if I was to write this out, there's two ways I could write this, and we're going to be going over this very soon when we talk more about inequalities. This is less than, negative 75 hundredths is less than negative 5/10. Okay, if you need to, you could put that 0 there and then compare so we have the same number of significant figures. Do you guys understand? Okay. Now, let me think. Another way I can write this inequality. What's another way I can write this inequality? Do you guys remember? There's two ways I could write it. Christian.
Negative 75 is.
No, you got to use one of these symbols.
You can put the equal.
They're definitely not going to be equal. Nope. No way. Go ahead.
You can switch them around.
We can switch them around, right? So if we switch these around, and instead of using the less than sign, we can use what sign? This means the same thing. It's just another way to say the same thing. See how I changed the direction of the sign? Isn't the inequality, the open part of the equality, still facing the bigger number here? Okay, I'm just trying to get you guys ready because we're going to be solving inequalities, solving equations, and I want you guys to understand these mean the same thing. Christian, I sent you out right before class. You're going to have to wait. Okay, can you guys go ahead and compare these two? When you're done, put your pencils down. When you're done, put your pencils down. Okay, we do have a quiz over this tomorrow, and I'm walking around the class, and I'd say most of you guys are doing what you're supposed to do. About 75% or 3/4 of you are trying. We have a quiz tomorrow. Some of you guys are giving me excuses on why you're not trying, because you didn't bring your paper or whatever. Now, who can tell me, who can share with the class, what is the decimal value, or do I need to rewrite this as a decimal? So we already went over a way. Who can walk me through another way to compare these two fractions? Fatima?
You could change the 2/3 into a different fraction by multiplying the numerator and denominator by 2.
Okay, so you chose taking 2/3, and you wanted an equivalent fraction, and you're going to multiply by 2 to get this equivalent fraction. And why did you choose 2 specifically?
Because the denominators have to match in order for me to compare.
Very good. So you want the denominators to match. So the other fraction we're comparing it to is -6, -1/6. Okay? And so when we rewrite -2/3, the numerator 2 times 2 is going to be what? 4. And the denominator 3 times 2 is going to be what? 6. So we have -4/6, and we're trying to compare that to -1/6. So which way is my inequality going to face? Because they're not equal. Saki. I'm comparing these two fractions. Fatima did all the hard work for you. Now we just got to compare. Which ones use one of these 3 symbols? Less than, greater than, or equal to? What's that?
The one that goes to 4, 6.
Okay, can you come up and draw the inequality that goes between these two fractions? Just the tip of the pen only. Okay. Is he right?
No. Yes.
Some of you guys are saying yes. Some of you guys are saying yes. Some of you guys are saying no. Miles in the back, can you help out?
He's not right because both of them are negative.
Right, right.
The smaller number, which is -1/6, is a bit greater.
The smaller magnitude is -1/6, and it's closer to 0, right? I think I'm trying to get you to use the correct terminology. 4/6 is the greater magnitude, and -4/6 would be farther to the left of 0. So that means that would be less than. So what you're saying is correct. I'm just trying to get you to use the correct vocabulary. So spot on. Did you guys hear what he said?
Yeah.
Okay, we're dealing with negative numbers here. And so when we just consider the magnitude, this is greater because it's closer to 0 and it's further to the right. Okay? You guys understand? If you need me to show you, watch. I'm going to draw a number line really quickly. So if this is 0, and let's just say that this is -1, and this is -0.5. Okay, about 4/6 is actually going to be, -4/6 is actually 3/6 would be half, right? So 4/6 would be somewhere over here. I'm just going to guess. So I'm going to say this is about -4/6. Do you guys understand? And then 1/6, well, that's going to be closer to the origin 0, right? It's going to be farther away from the half, toward the 0. So I'm just going to say it's roughly right about here, -1/6. Okay, so do you guys understand why it's less than? Are we good? Any questions? Yep.
I thought the number would be further away to be greater.
No, when we look at the number line, the ones on the left-hand side, any number to the left of another number is less than. So if you look at the number line above in the classroom, take a look at these. Pick any number. 80. Look to the left of it. Any number to the left of it. Any number on the left-hand side of 80 is less than 80. Do you understand? And that's the same when you're talking about negative numbers. If I look at -1, do you see that all the way in the back? Any number to the left of -1 is going to be less than -1. Do you understand? Okay. Any questions? Can we move on? Okay, compare these two fractions. This is an easy one. This kind of goes right back to what Miles was talking about. Take your guess. Hopefully it's not a guess. Hopefully you know it. And Glorabelle, can you share with the class your answer? What is your answer?
4 and 7/10 is greater than.
Right. So 4 and 7/10 is greater than. Why'd you say that? So we can say it that way, or we can also say it by flipping the direction, right? I can move this. I think this is what you said. 4 and 7/10 is greater than -4 and 4/10. Okay? But if you take and consider this, and hopefully this will kind of make it more concrete for you, take a look at this next comparison. Do you guys see the next comparison? What changed? They're both negative now, but did the magnitudes change? No, the magnitudes didn't change, but the direction changed, which side of the origin, right? So now we got to think about this a little differently. So let's move to Carter. Carter, can you share with us what's the answer for this next comparison? Is what? Nice. So we have -4 and 4/10. And you said that's going to be greater than -4 and 4/10. 4 and 7/10, excuse me. Is there another way I can say that? Carter, do you have another way to say that? Nice. Good. So when we get to inequalities, because there's like a whole, there's several lessons on inequalities and solving inequalities, I want to get you guys comfortable with that. Okay, and I even have a number line for you. Okay, next, here we go. Can you guys compare these two? Make a comparison between these two. You got it? Really quickly, write it down. I see a number of hands that went right up and didn't write anything down. I need you to make good notes. Okay, I believe I've called on everybody in these first 3 rows, so I'm going to try to move over to this other side of the classroom. Saki, I already called on you. Timothy, have I called on you today? Timothy, can you share with the class your comparison?
4 and 9 tenths
Uh-huh.
is
Greater than.
4 and 2 tenths.
Do you guys agree with Timothy?
No.
Can we help him out?
The opposite.
Right, we're talking about negatives, right? So let's visualize where it is on the number line, okay? Which one's further away from 0? 4 and 9 tenths, right? And it's on the left side, right? So if we think about the number line, here's 0, and I'm just going to say that I'll make this 4, and negative 4 and 9 tenths is going to be really close to 4, right? Negative 4. But then I have negative 4 and 2 tenths. That's going to be not as close to negative 4 as negative 4 and 9 tenths. Do you understand? Right, so it'll be somewhere over here, negative 4 and 2 tenths. And that's not to scale, but do you understand what's going on? Okay, this isn't perfectly to scale. This should get you guys to visualize which is closer to 0, which is closer to negative 4. So if I write that up, how would I write that up? Timothy? Negative 4 and 2 tenths, very good, is greater than negative 4 and 9 tenths. And there's another way I can write this, right, Timothy? What's the other way I can write this? Okay, we can say 4 and 9 tenths is less than what? Right.
Excuse me, Mr. Heatherly?
Yes.
Can I have Tiana Saki to the front desk?
Yes, she's on her way.
Thank you.
Okay, any questions about that problem? Any questions about this one? Okay, let's move right along.
Put to the front.
Quiet, please. Hopefully we can save this. What are you guys all manning about? Okay. Next slide. Shh. Now, we're almost done. Let's try to finish this up. When you compare and order decimals and fractions, it's often helpful to write the fractions as decimals. Ordering rational numbers. The peaks of 4 mountains or seamounts are located either below or above sea level as follows. So if it's a positive number, is it above or below? Above. What about this?
Below.
Negative 2/10 of miles below. What about this one? Below. The next one, negative 2/9 mile below. What about this one? 1 1/10 mile above. Okay, we need to order it from least to greatest. So help me out. Miles, I already called on you. I already called on Armani, sorry. Which of these numbers is the smallest of the group? Which one would be farthest to the left? Armand. Shh. Please stop calling out a turn. Yep. Take a guess. Which one do you think is the smallest one of these 4 numbers? Which would be the furthest left on my number line? What's that? Negative 0 and 2/10. That's going to go over here. Okay. And then what's the next smallest number? What's that? negative 1 and 1/10, that's a positive number though, right? We still have a negative number to deal with, right? Do you see it? Negative 2/9. Well, negative 2/9 is going to be a little bit, if I compare negative 2/9 and negative 2/10, which side of negative 2/10 would that be on? Remember that strategy? If the numerators are the same and the bottom number's larger, do you guys remember that strategy from the earlier lessons? You can compare the two. Think about this. If I have 1/4 and 1/2, which one's the smaller amount? 1/4, right? So if I have negative 2/9 and negative 2/10, negative 2/9 and negative 2/10, excuse me, young man, have a seat. We still have 10 minutes. I'm not sure what's going on with the behavior today. It's really lousy. I need you guys, I sent you right before class. You asked to go, I let you go. I'm not sending you again. So whatever you did right before class, that was your time. I'm not writing another pass. So if you went out to play, I'm sorry, that's on you.
Staff. Please disregard the bell you just heard. Please disregard. Thank you.
So which one is smaller? Shh. I need to get through this lesson, and you guys are making it difficult today. Which one's smaller? Go ahead, Logan. 2/10 is going to be smaller. 2/9 is going to be a little bit larger. Okay, maybe there, maybe not. Now what's my next larger number? Alexis? 1/4. Very good. And that's going to be about 1/4, right? So right about here. And what about the last thing? We have 1 and 1/10. So over here, 1 and 1/10, right about there. Okay? So we have it arranged from least to greatest. Now, if you guys can go ahead and take care of this, arrange these from least to greatest, and then we're done. Quickly. Did you write it out? Okay. Caleb, what's the smallest number we got here?
Smallest number is 6 1/4.
Negative 6 and 1/4. Very good. So that's the smallest. What's the next smallest? Who's got the next smallest? Uche, go ahead. -4. Very good. Okay. What's the next smallest? Who's got the next smallest? Who haven't I called? Ola, go ahead in the back.
6.55.
Right. And then the last one is 12.5. Did you guys get that? Pretty easy? Nice. Okay, last slide. In your own words, define rational number. Can somebody give me a definition of rational number in your own words? Who's got it? Anybody, because I've gone through the whole class now. Timothy, go ahead.
Rational numbers is when you compare, like,
It's not comparing, it's a type of number. Go ahead, Armani. It's not the comparison of two numbers. It's a number that we can always write a certain way. Think back to the first slide. Remember the examples we had? All right, Ola, go ahead.
rational numbers are numbers that can be divided by 0 but can be divided.
You can't divide. It's a number that can't. It can't have a 0 in the denominator. But you're on the right track. A rational number. You need to know this. Oops, that's not what I'm looking for. Delete. A rational number is a number that can be written as a fraction. Okay, here's the definition. Okay? And compare these two. Which one's greater than? Less than or equal to? What about this one? What's the symbol here? Less than? What about this one? Equal? Are you sure? Greater than? Nope. Is 3/4 greater than or, oh, but we're backwards, right? So that's good. What about this one? What? This is less than. All right, moving right along. Order from least to greatest. What's the least out of this group? Negative 236. What's the next least? Negative 7 and 1/7. What's the next least? Negative 3 and 3/10 repeating. What's the next least? 0. And then 41/99. Okay, let's do this one. What's the least out of this one right here? Least. Negative 8 and 1/3. Good. What's the next one? Negative 8 and 22/100. What's the next one? Negative 8. What's the next one? Negative 5 and 1/3. And the last one is going to be what? 16 40 seconds. And that is the end of my lesson.